This is the Unit 9 review, page 1. Graph the system of inequalities. On number 1 we have y is less than or equal to 4, y is greater than 1, and x is greater than or equal to negative 3. Since the first two equations only have the letter y, these are both horizontal equations. So I'm going to start at where y is 4, less than or equal to, so I need a solid line. And everything where y is less than 4 means I need to shade downwards. The second line, y is greater than 1, another horizontal line. I'm going to start at y equals 1. This is not greater than or equal to, so I need a dotted line. Greater than means I need to shade everything above all the values where y is bigger than 1. My last line, x is greater than or equal to negative 3. This is an x equation, so this is a vertical line. I go to where x is negative 3. Greater than or equal to, so I need a solid line. And x values are bigger than negative 3, going to the right. My solution is the part where all of my shading overlaps. So between my two horizontal lines and to the right of my vertical line, my solution is everything in here and on the solid lines. Number 2, x is less than 3 and x is greater than negative 2. I'm going to start by noting that these are both x equals equations, so they are both vertical lines. I'm starting at where x is 3 and I need a dotted line. And x is less than negative 3, so, less than positive 3. Less than is everything to the left. My second equation, x is greater than negative 2. I'm starting at negative 2. This is another dotted line. And x is greater than, that means I need all the x values greater than negative 2 or to the right, and I only care about the overlap part. So my solution is the space in between my two vertical lines. Number 3, x plus y is greater than 3, and 4x plus y is less than 4. These are both in standard form. I'm going to start by getting these equations into y equals mx plus b, so they are easy for me to graph. X plus y is greater than 3. I want to solve for y, so I'm going to move the x to the other side. And remember, I want y equals mx plus b, so I need the part with x first. Y is greater than negative x plus 3. So this line has a y-intercept of 3 and a slope of negative 1. So I'm going to go down 1 over 1. All the way across my graph and back the other way. This is just greater than, so I have a dashed or dotted line. To know which way to shade, I'm going to test the point 0, 0. So I'm plugging in 0 for y and for x to see if I get a true statement. I get that 0 is greater than positive 3, because 0 plus 3 is 3. This is false. So I do not need to shade 0, 0. So I am going to shade in the opposite direction. My next equation is also in standard form, so I'm going to start by subtracting 4x on both sides. And I get y is less than negative 4x plus 4. So for this line, I have a y-intercept of 4 And my slope is negative 4 over 1, so down 4 over 1. I'm going to go back the other direction, so I'm all the way across my graph. This is just less than, so again I need a dotted line. And I'm again going to test the point 0, 0 to see if my statement is true or false. I'm plugging in 0 for y and 0 for x. Negative 4 times 0 is 0, so I'm left with 0 is less than 4. This is a true statement, so for this line, I do need to shade towards the origin, towards 0, 0. My solution is the part where my shading overlaps. And my solution is this area in here. Moving on to the next page. Number 4, graph the system of inequalities. Okay, if I take a look at my first line, I have x is minus 4 is less than or equal to negative 2. I do not have a y, so I'm going to solve this for x. I'm going to start by adding 4 to both sides. And I get x is less than or equal to negative 2 plus 4 is positive 2. This equation only has x, so it is a vertical line. I'm going to start where x is 2. Less than or equal to, so a solid vertical line. Everything less than 2 is everything to the left of this line. My second equation, I have x plus y is greater than or equal to 0. I want to get this into y equals mx plus b, so this is easy for me to graph. I'm going to start by subtracting x on both sides, and I get y is greater than or equal to negative x. I don't really need to write the plus 0. So my y-intercept for this line is 0. The slope is negative 1, so I'm going down 1 over 1, all the way across my graph. And all the way back the other direction. Less than or equal to, this is a, greater than or equal to, excuse me. This is a solid line. And I'm going to test the point 0, 0 to see if my statement is true or false. Oh, notice, however, though, my graph already goes through 0, 0, so I'm actually going to test the point 1, 1. So I'm plugging in 1 for x and for y. And I get that 1 is greater than or equal to negative 1. This is false. So I need to make sure that I am not shading towards the point 1, 1. So I'm shading the opposite direction. And my solution is the area that overlaps. In this case, that is this area here. Number 5, graph 6x plus 2y equals greater than negative 14. I'm going to get this into y equals mx plus b format. So I'm going to start by subtracting 6x to both sides. And I now have 2y is greater than negative 6x minus 14. Next I need to divide by 2, but when I divide, I need to divide everything by 2. Negative 6 divided by 2 is negative 3. Negative 14 by 2 is negative 7. So my y-intercept is negative 7. And my slope is negative 3 over 1, so down 3 and over 1. I'm going to go back the other direction. Y is greater than, this is a dotted or dashed line. And I'm going to test the point 0, 0 to see if I should shade towards the origin or away from it. So I'm plugging in 0 is greater than or equal to negative 3 times 0 minus 7. Negative 3 times 0 is 0. So 0 is greater than negative 7. This is true. 0 is always bigger than negative numbers. So I am shading towards the origin. My solution is everything in that shaded area. Graph x plus 5y is less than 25. Again, I'm going to get this into y equals mx plus b format. I am solving for y, so I'm going to start with subtracting x on both sides. 5y is less than negative x plus 25. I need to divide everything by 5. Remember, there's a negative 1 in front of that x, so y is less than negative 1 over 5x. 25 over 5 is 5. So my y-intercept is positive 5. And then I'm going down 1 and over 5 for my slope. Down 1, 1, 2, 3, 4, 5. Y is less than, this is a dotted line. Okay, again, I'm going to test the point 0, 0 to decide which way I need to shade. So I'm plugging in 0 for y and 0 for x. Negative 1/5 times 0 is 0, so I have 0 is less than 5. This is true. So I need to make sure that I shade towards the origin, towards the point 0, 0. Okay, moving on to number 7. Graph 4x minus 3y is less than negative 9, and y is less than 2x plus 3. Starting with this first equation, this is in standard form. So I have 4x minus 3y is less than or equal to negative 9. I'm going to get this into y equals mx plus b format. So I'm going to start by subtracting 4x on both sides. And I get negative 3y is less than or equal to negative 4x minus 9. Next, I divide everything by negative 3, but be careful, because remember, when we divide by negative 3, we have to flip that inequality. Negative 4 divided by negative 3 simplifies to positive 4 over 3, x. Negative 9 divided by negative 3 is positive 3. So my y-intercept is positive 3. And I have a slope of 4 over 3. So I'm going up 4 over 3. And back the other direction. Less than or equal to, so this is, greater than or equal to, this is a solid line. And I'm going to test the point 0, 0 to see which way I need to shade. 0 is greater than or equal to 4/3 times 0 plus 3. 4/3 times 0 is 0. So 0 is greater than or equal to 3. This is false. This is not true. 0 is not bigger than 3. So I do not need to shade towards 0, 0. I need to shade away from the origin, or in this case, above the line. My second inequality is already in y equals mx plus b format, so my y-intercept is positive 3, same spot, but my slope is positive 2, so up 2 over 1. I'm going to go all the way across my graph and back the other direction. Less than, so this is a dotted line. And I'm going to test the point 0, 0 to see which way I need to shade. 0 is less than 2 times 0 plus 3. 0 is less than 3. This time, this is a true statement. So I need to shade towards the origin. And notice the only part of this line that overlaps is this tiny area right here. So that is my solution area. Graph x plus 3 is less than negative 1. This needs to be in y equals mx plus b format, but I notice I don't have a y, so I am just going to solve this for x by subtracting 3 on both sides. X is less than negative 4, so I'm starting where x is negative 4. This is an x-only equation, so this is a vertical line, and it's less than, so it needs to be a dotted line. And x is everything less than negative 4, that is everything to the left. Part 2 of this review will start on the next video, and I will start on number 9.